Why do we use differential equation to express nearly everything in our universe? The answer to this question is interesting, as it is surprising. Now, let me not get over myself here. We first need to understand what is a differential equation. And put it simply, it's an equation containing a function with its derivative. There are usually two types of differential equation. The first type is referred to as ordinary differential equation. This type of an equation has a single independent variable with its derivative. Let's look at an example. This example here has one independent variable, which is t, respectively. The next type of differential equation is referred to as partial differential equation. Unlike the previous one, this one has more than one independent variable with its partial derivative. Let's take a look at an example. This example here has two independent variables, t and y, respectively. Now that we understand what differential equations are, let's take a look at just how much we interact with these equations without realizing it. For instance, how the cell phone sends and receives signals.
Differential equations can also be used to model how planets in our solar system orbit around the sun, to how news and memes spread across the world, the behavior of anything that oscillates, that we see this behavior in our daily lives, how objects in space orbit, to describing the motion of an object that touches something and thus exerts a force, to describing and modeling the spread of pandemics like the coronavirus across the globe in order to see the affected countries and what can be done. Oh wait, even washing dishes. I can use differential equations to model the rate of change of dirty dishes with respect to time. Pretty cool, huh?
But why do we use differential equations? The answer to this, as I stated earlier, is interesting, as it is surprising. You see, differential equations allow us to use our current information to predict the future. And to put all this into perspective, let's consider an algebraic expression compared to a differential equation. An algebraic expression that describes a general formula for circles is considered to be x squared plus y squared equals r squared. And this equation, when graphed, it will give you a circle that is pretty restricted based on its radius. But if you were to take this formula and turn it into a differential equation, you have an equation that has a function that describes a family of circles. And hopefully you can see just how powerful this is. Mathematicians, engineers, all see the world through differential equations. Now that you understand what differential equations are, hopefully you too can see the world just like they do.